Good afternoon, children. In our today's class, due to disrupted net connection, we could not discuss the question answers that very well. So, doesn't matter. Here I am posting this video for you to so that you can get a fair idea about the question answers of the a few in-text ones and rest of a few from the exercise part. So, we shall take the last of the in-text questions first, and here it goes your first question, and this question reads like, what modifications can you suggest in the Hardy-Schulze rule? You see, Hardy-Schulze rule only discuss about the charge on the flocculating ion. Fine. The size is nowhere discussed. The size is nowhere given any importance. But from our knowledge of class 11th polarization of ions, we can very well correlate that smaller the size of the ion, larger is its polarization power. And polarizing power is what plays an important role in the neutralization of charges. Fine. So if we can include the polarizing power of the ions along with the charge, that will make our Hardy-Schulze rule more better. Right? It will give us much better a picture to select a suitable electrolyte for the coagulation of the colloidal particles. The next question goes, why is it essential to wash the precipitate with water before estimating it quantitatively? Quantitatively means drying out our we will be drying our precipitate first, and then if we do not wash this precipitate properly, the remaining amounts of electrolytes and the other substances will remain absorbed onto the precipitate particles, number one. And number two, the remaining amount of your electrolytes disturb the precipitate and may break it into smaller particles, which will sieve down through the uh, your filter paper, and thereby it will affect the results of the estimation. Therefore, it is very necessary to wash the precipitate. So, what are the two reasons? Number one, to remove the adsorbed particles from the surface of precipitate ion, uh, which will affect the weight of the precipitate. And number two, also to wash out the remaining amounts of electrolytes, which will uh, break down the precipitate into colloidal particles, and thereby they will be left behind in the filtrate and will affect the weight of the precipitate, and therefore the readings of the experiment will have a large error. Next, we will be discussing a few exercise questions, children, and the number one of these is, distinguish between the meaning of adsorption and absorption. Simply, uh, if you remember the video shown where I took the example of a chalk piece, if the ink is observed only on the surface of the chalk piece, then we can say it is adsorption. But if you see the ink is evenly distributed throughout the chalk piece, then you will see the ink is absorbed. Fine. So adsorption is simply accumulation of particles onto the surface, and absorption is penetration of particles inside the bulk of the substance. So coming to the question number two, difference between physisorption and chemisorption. Children, this question may be asked for 1 mark, may be asked for 2 marks, and may be asked for 3 marks. When it is asked for 1 mark, you will be giving number one, the definition of the physisorption and chemisorption, and number two, you will give the force of attraction between the adsorbent and adsorbate in the two. So I am discussing this question for the 2 marks. Number one, physisorption is the phenomena in which the adsorbent particles are held adsorbate particles are held together with the van der Waals force of attraction, and whereas chemisorption occurs due to the chemical bond formation between adsorbate and adsorbent. Fine. Number two differences, physisorption is due to van der Waals forces of attraction, and chemisorption is due to formation of chemical bonds between the surface and the adsorbed particles. Number three, very important, is physisorption is favorable at low temperatures and chemisorption is favorable at higher temperatures. Number 4, physics option does not involve any activation energy, and chemist option involves activation energy. Right? So these are the main points of difference between physics option and chemist option. Next comes the reason why finally divided substance is more effective as an adsorbent. Finally divided adsorbent provides more surface area, which will lead to the more adsorption, and therefore more reactants will be catalyzed. Then question 4, what are the factors which influence the adsorption of a gas on the solid? Now two factors will influence the gas, and one important factor of the solid substance will be playing a decisive role. The gas, number 1, should have larger partial pressure. Number 2, the gas should be at low temperature. Number 3, the solid substance should be finally divided, and you can say the surface area should be more, so that more of the gas can be absorbed. Adsorption isotherm, this is simply a plot of extent of adsorption against the partial pressure of the gas. Fine. And Freundlich adsorption isotherm, you will discuss it in terms of the Freundlich equation, then its logarithm equation, then the plot of x by m versus the pressure. Fine. Then question number 6, what do you understand by activation of adsorbent? Activation of adsorption simply means making the active sites available for the adsorption. And how can it be achieved? If we heat the adsorbent, then the molecules which are already present and already occupying the active sites may be desorbed from the surface, and thereby the adsorbent will be activated, or you can say the surface now will be available for adsorption of fresh molecules. 7th, what role does the adsorption play in heterogeneous catalysis? In heterogeneous catalysis, adsorption of reactants onto the surface of catalyst provides an alternative pathway for the reaction which have low activation energy, and therefore the rate of reaction is increased. Why is adsorption always exothermic? Yes, adsorption is always exothermic because here it is the adsorption simply means physics option. Here we are talking about adsorption, physics option, or you can say adsorption is exothermic because it happens due to the uh, due to the due to formation of van der Waals forces, and van der Waals forces are more active at very low temperature. Therefore the energy is released so that the temperature at the adsorption site is lowered and more of the gases can be absorbed. Now the 9th question, how are the colloidal solutions classified on the basis of physical states of dispersed phase and dispersion medium? You see children, on this basis we have 8 types of colloidal solutions which are given there in the table, in the tabular form in your book. You can refer to that table. Then discuss the effect of pressure and temperature on the adsorption of gases on solids. In this case, you will make use of Freundlich's adsorption isotherm, and you will discuss this effect in terms of adsorption capacity, adsorption extent, that is in terms of x by m against the partial pressure of the gas. Now children, then what are lyophilic and lyophobic salts? Give one example of each type. Why hydrophobic salts are easily coagulated? Simply lyophilic salts are the salts in which there are attractive forces between the dispersion medium and dispersed phase, whereas lyophobic salts do not have attractive forces between the dispersed phase and dispersion medium, and they are therefore unstable. And why the hydrophobic salts are easily coagulated? Because they do not have any attractive forces between them. So as soon as the collision between the dispersed phase particles, the collisions between the dispersed phase particles lead to their coagulation by the discharge of their charges, right, and loss of kinetic energy. Then what is the difference between multimolecular and macromolecular colloids? Multimolecular colloids are aggregates of the smaller molecules, whereas the macromolecular colloids have molecules which are having very large molar masses, right?